We're going to be on this page here where it says at the top, angles in triangles. Okay, raise your hand if you're tired of proofs. Okay. Good news is that the second half of this unit is a lot less proof heavy. Okay. We're still going to see some proofs, but you're not going to necessarily be writing them yourself. You're going to be using proofs to kind of show why certain things in these triangles happen. But we're not going to be writing a whole bunch of proofs in the second half of this unit. We're more going to be focusing on properties of triangles. Like, what do their sides do? If you know that the triangle is this kind of triangle, what does that mean? What do the angles do inside of a triangle? And some of those things you guys probably already know. Just because I know in the past we've talked a little bit about triangles, or we've seen it show up on a worksheet, and you guys are able to tell me some stuff about it. So some of the stuff we do is probably not going to be like brand new information. We're just going to kind of solidify what you've learned before. Like I said, we will still see a couple of proofs, but it's mainly going to be in our notes where we're writing down the statements and the reasons. And I will give you like a warning if there's going to be something that you need to study so that you know to prepare for it for the test. Okay? So if you guys look at this first page, the first thing that we are going to start off with is a proof. But like I said, we're going to write this out together. And what we're trying to prove is that the sum of the measures of internal angles of a triangle is 180 degrees. So I want to talk about this for a little. I circled a couple things and I underlined something. What does that word sum mean? You're adding, right? So they're talking about if we add the three angles together in a triangle, that they should equal 180. But they specifically say the internal angles, okay? If you didn't know, there are actually exterior angles on a triangle that can show up. How they belong, I'm just going to zoom in on this picture and show you. We're not going to focus a ton on this, but I just want you guys to understand. If I were to extend AB out, so if I were to have that side go out like this, there is actually an exterior angle right there that we could be doing some stuff with. And exterior angles on shapes, they have their own set of properties. They do their own special thing. We're not going to focus a whole lot of time on that, but I just want to talk to you about why are they saying internal angles here. I could really do this to all three sides of my triangle. I can extend BC out this way, and there'd be another exterior angle here, and I could extend CA out this way, and there would be another exterior angle there. When we talk about the internal angles, I'm talking about those ones right now that are labeled 1, 2, and 3. I'm not talking about these ones on the outside. But that's why they're specifying, because there are external angles on a triangle and on any other shape that you have. You could extend the sides on any shape and have them do the same thing. And they do things. Like there's some stuff that we could get into about exterior angles. We're just not going to do that right now. Okay? But I'm going to kind of get rid of this, but I just wanted to show you that. And I want us just to focus right now on these interior angles. Now, if you look at this picture right underneath it here, you guys think these pictures look pretty similar? What's different about that second one? There's a parallel line that they added on like the top half of the picture. Going through that point B, they had like another point D that they called, and they drew this parallel line in there. And then when they did that, it created a couple of other angles, and some of them we would maybe consider to be exterior because they're on the outside of that triangle. That's where like the 4 and the 5 are. Okay, so we need to use that and kind of use what we think about what's going on in this picture to help us prove this. So if you look over here, kind of zooming back out, we're given that this triangle ABC exists, and it's got angles 1, 2, and 3 in it. They did construct what we are calling an auxiliary line that's parallel to AC through B. They've already done the construction for us. They're not making us do that. But that's where they got that parallel line from. They did a construction. We've done constructions like that at the very beginning of the year. We had to construct a line that was parallel to another line through a specified point. So that's what they kind of did up there, and they're showing that with that dotted line. That's the construction that happened. We want to prove that those three angles on the inside of the triangle should add up to 180, okay? So down below, they already have kind of our given information provided. We have that parallel line in there because of our construction, okay? So now let's get into how do we start to get to our proof statement? We can't just jump right there. But we want to try to prove that 1, 2, and 3 add up to 180. So maybe I need to look at my picture and see if there's other angles that also add up to 180. Because then maybe I can create like a path to 1, 2, and 3. So if you guys look at your picture and mainly look at this one down here on the bottom with the parallel line, do you guys see some angles that if you put them together, you think they would add up to 180? 4, 2, and 5. Now, I wouldn't maybe call that technically like a linear pair, right? Because there's more than 2 angles here. A linear pair, we said, pretty specifically had only 2 pairs. But I agree that these 3 angles here, kind of side by side, they make up that parallel line that we see on the top. So I think it's probably safe to assume that those 3, if we added them together, would equal 180 degrees. So I'm going to write that down for step 2. I already have step 1 here. They didn't number it for me, so I'm going to go ahead and add a number, 1. And then step 2 is I'm going to write down what Parker just said. 4, 2, and 5, if I add them together, should equal 180. Okay, because they make a line. Like I said, I can't really call this a linear pair because there's more than 2 angles, but they still make a line. Lines still have 180 degrees in them, so this reasoning still works. All right, now I kind of want you to think back to your proofs from like even the last unit, not the ones that we've been talking about so much with the triangles, but like parallel line proofs. When we had parallel lines and transversals, there were some angle pairs that showed up. Do you guys see an angle pair that would maybe connect like 4 and 5 to these angles down here, 1 and 3? What do you think, Parker? 4 is alternate interior with 1. Okay, so let's just kind of think about that. This is our parallel line. If we use this as our transversal, are 4 and 1 alternate interior, like he's saying? Yeah. What do we know about alternate interior angles with their measures? They're congruent. So over here for step 3, I'm going to go ahead and write down what you just said. Angle 4 and 1 should be equal to each other because we know that their measures would be congruent since they're alternate interior angles. What about 5 and 3? If I switch my transversal to this line, do 5 and 3 do something? Are they the same? Are they also alternate interior? Yeah. So what's true then about these measures? They should also be congruent. Okay, so I'm going to go ahead and write that down here. I'm going to include it on the same step. So measure of angle 5 should be equal to the measure of angle 3 because they're still alternate interior angles. Okay, I've been able to kind of establish a connection between 4 and 1, 5 and 3. That might be helpful now because my original statement needed to have angles 1, 2, and 3 in it. I started out with a statement that said 4, 2, and 5. I don't have any issue with the 2. How can I get the 4 and the 5 to become 1 and 3? Great.
You sub in 1 for number 4 and you sub in 3 for number 5. It's like trains.
Well, I think what you said is what your reason would be. You said sub in, right? So wouldn't that just be substitution?
Yeah.
Like if I'm gone for the day, there's a substitute teacher here in my place, right? We talked about substitution in the past. I think that's when I picked on Stryker and I said, like, if he's gone in a game, someone else who plays in his same position has to sub in for him, okay? When we're replacing angles like this because they're equal, we're just substituting in exactly like what you said. So I'm going to go ahead and write that down. The measure of angle 1, because I'm substituting 4 for 1, plus the measure of angle 2, plus the measure of angle 3, because again, we're substituting 5 for 3, should equal 180 because of substitution. We're just doing a real simple swap. So we're just subbing in. That's why we know that in triangles, those 3 angles are always going to add up to 180. That's kind of the proof that established that this is going to happen all the time. So just like we had proofs for vertical angles and we had proofs for corresponding angles, like that's why we can just continue to use them over and over and over again. We don't have to like keep going back and reproving things. Okay, but this proof, guys, is really important that you guys understand how it works and what it looks like, because you're going to see this proof show up on your test. And you're going to have to be able to replicate it, like write out the steps, write out the reasons. So I don't know how you need to notate that for yourself. Put a big star by this proof or something. You need to memorize that because it's going to show up on your test. So like I said, our test isn't going to be until next week. I'm giving you like a week's warning here to start looking that proof over and start getting those steps memorized for yourself so that when you see it on your test, you guys can just write it out again. Okay? Everyone understanding what I'm saying? A couple of you are nodding at me. A couple of you have checked out already. Okay, let's go here to the bottom. We're going to start using that property that we talked about up above, that the angles add up to 180 to solve for missing angles here. So I want to start by solving for the measure of angle A on this first picture. Okay, what do you guys think we should do? Jackson?
I know what angle B is because it looks like it's a right angle.
Looks like they have that little box in there. So I think we can say that this is 90.
So we add the two together and then you subtract that from 180.
Okay, so I'm going to write out what you said. You said add the two together, subtract it from 180. Everyone agree with him? Yeah, we know that those three angles should add up to 180. So he's going to add the two that he has and then get rid of that to find out the remainder. How much does that come out to be? 58. So angle A is 58. How could you check? How could you check that you did that your math right there? If you plug it in, so if you know that this is 58, what should those three angles do?
Add up to 180.
They should add up to 180. So if you wanted to do that really quick and add them up, that would be an easy, fast way to figure out if you did it right and you got the correct number there. Okay, let's go down over here to B. What are those little circles trying to tell you? That they're the same. So A and B in this picture are the same measure. You know how much C is. C is 50. I just want to know how much angle B is. I'm sorry, angle A. How do I do it? Keegan? Good. 180. Subtract the 50 you have. We're cutting it in half because we know that those two remaining angles need to get the same amount. How much does that come out to be? 65? Yeah. Again, if I check that, 65 plus 65 plus 50, that should get me 180. Okay, C, we're switching things a little bit here. They're not just giving you numbers for all the angles. We also have some letters thrown in here. They want us to solve for X. Logan, what do you think we should do?
What I did was I added the numbers inside together. There's a little, I can't remember exactly. I didn't write it down.
Okay. But when you said add up the numbers, did you just focus on the 48, 60, and 80?
Yeah, I added those together.
Okay.
First.
What did you do with the X's?
I put them to the side for this now.
Okay.
So then I subtracted that number from 180.
Okay.
Giving me, and the number was 188.
And then you took 180 minus 188, and you got negative 8. That's what your X is?
No, then it says there's two X's I divided by 2.
Since there's two X's in there. Okay. So that's perfectly fine. Someone might not remember that you put aside two X's, though. So is there a way we could write this out without thinking about putting things separated? Keegan?
180 equals 2x plus.
So you're already combining your things?
Yeah.
Okay. Could I just even go back one extra step and do it this way?
Yeah.
Because this is what you were doing mentally, correct?
Yeah.
You were already just adding the things together to get what you said was 2x plus that 188 equals 180. right? Everyone following here? We're just adding those same like 3 angles up. They're still going to add up to 180 here. We're just combining like terms. X's go together, our numbers go together. Okay, and then we do that process that kind of Logan was explaining. He subtracted the 188 from 180. That's how he got -8. He divided by 2. He got -4. Is it a problem for me to get a negative answer for X? No. What would be reason for concern, though? If I got a negative angle, okay? Last period I said we have talked about negative angles before, but only in the term of rotation, like turning directionally. We've not talked about negative angles measure-wise. Like we've never measured a negative angle. We've never talked about a negative measurement of an angle, just like we've never talked about negative segment measure. So if you plug X back in and you get positive answers, you should be fine. If I were to plug that -4 in and I get negative angles, that should be like red flag, I did something wrong, I need to go back and check what I did for X, okay? Now, they do say check down here. You're not required to check it. But if we put -4 back in for these X's, this angle would be 76, and this one would be 44. If you add those up, 44 plus 76 plus 60, what do you get? 180. That checks out, and it lets you know that you did it right. Okay? So again, I'm not saying you have to check all your work, but on like a day of a test, if you have like 10 minutes left of class, it would be wise to go back through and check your work and see, do I feel really confident about what I did here? Or if there was any problems that you were feeling a little bit iffy about. Especially like first period, I said, what would cause reason for concern? And someone said, if I got a decimal. It's okay if you guys get decimals, just like it's okay if you get a negative answer. But if you feel a little bit uneasy about it when you get a negative or you get a decimal, check it. Plug it back in and see if it works out. Because if it does, then you're probably right. All right, we've got a couple more. This next one wants us to find 2 things. The measure of angle B, which is this one here. Angle B is just up here by that letter B. And then the other one it says is BCA. So if you trace those letters, they're talking about this angle here. That's BCA. All I know right now is that in that triangle, there's a 21 degrees, and then on the outside, there's a 65. Anyone have an idea of what to do? Keegan, what do you think?
Like draw like the half circle over like C and 65 because that's equal 180.
So like this thing?
Yeah.
Because what do they make?
Supplementary angle.
What's that name we call those when they're side by side like that? Linear pair. They make a linear pair. They're supplementary, like you said. So what would you do?
180 minus 65.
Okay, so that would be for BCA. 180 minus 65. What is that? 115. Okay, so that's this angle here. I'm going to write that 115 right there. Okay, now can we find angle B? Okay. What would you do?
I subtracted 115 and 21 from 180. 65.
It's not 65.
Is it?
Mm-mm. There's no parallel lines in this picture, so we can't use alternate interior. What'd you say? 44. I understand why maybe you thought that, okay? Because when we did our proof, we did talk about alternate interior angles. But in our proof, we had parallel lines. Yeah, there's no parallel line in this picture, so we can't have alternate interior angles being used right now. But yeah, when you subtract those 2 angles from 180, you should have gotten 44. And again, you could check that. You could add 21, 44, 115. That should check out to be 180. Okay, last one we have here. They want us to figure out how much that question mark is worth. What should we do? Kind of got to work from the bottom up. Parker?
60 is a vertical.
You see vertical angles? This angle here is vertical to this angle, so we know that this one should also be 60. Perfect.
And then it's alternate with the question mark. I think the 2 parallel lines.
Well, we don't know that those lines are parallel. We don't know that for sure. Sophie? with the angle right next to it? So these two should add up to 180. So it's 30. Good? Logan?
Yeah, if you add those together, you get 90, and then double that's 180, so it'd be 90. At the top.
Okay. So you added 60, 30. You subtracted that from 180 to get this angle here. You took 180 minus that 60 and 30, which is 90. So you got 90 again.
Yeah, and then it's a vertical angle.
Then we have another vertical angle. Good. How can we finish this off? Parker?
Not, 90 plus 20 minus
And how much is that? 62.
Yeah.
So, do you kind of see how now they're not true alternate interior angles? They look like it. So, this is kind of going back to what we've talked about in the past. We can never assume something's happening in a picture. Unless they notate that, like these lines, if they put those arrows on there telling you that they were parallel, we can't make assumptions that they are. Okay? But I totally understand why we think that. I get where kids get that from because you've seen pictures that kind of look like, and I would argue, yeah, those lines do look like they're parallel, but they're just off by a hair. And so we get 62 instead of 60. So it's always good to kind of go back through and check like we did there. Questions on any of those problems? Feel okay about that? Okay, that's where we're going to stop for today.